Valadez, replacement manager here at Temple Mechanical. I'd like to welcome all of you to today's training video. We have Mr. Brandon Sedlak with us from Lennox Industries. He's going to be going over best installation practices and troubleshooting tips for the iHarmony equipment. Mr. Brandon, thank you very much. Pleasure having you here.
Thank you, sir.
It's all yours. Thank you.
Great to be here. Thank you, everybody. All right, my name is Brandon Sedlak. I'm the field technical consultant for Lennox here in this area. I think you're probably more familiar with Ken Rollins. We've done a little bit of reorganization here recently, and so I'll be working with you folks. I've been with Lennox for 15 years. Started my career there. I was there for several years working in a research lab, working in commercial technical support. I left for a few years and then came back in 2014. So I've been back working in a tech support role, working on product applications. I've recently started here earlier this year and as a field technical consultant. And so one of the things that I love to do most is to train, to teach, and to help others to get better. That's a big thing that Lennox is about internally, and I certainly like to share that with our customers. One of the things I want to make clear in this training, of course I'll be doing it primarily in English. I also speak Spanish. Entonces, si alguien necesita aclarar algo en español, we need to clear it up in Spanish. Sin duda alguna, me deja saber con mucha confianza. También puedo, hasta la fecha no tengo mucha de esa información traducida, pero estamos trabajando en eso. Entonces, si quieren más información así en español que les va a ayudar, déjame saber y podemos hacer algún arreglo, porque queremos trabajar más en eso. We're trying to get more things done in Spanish to help communicate better with our customers. So, iHarmony zoning. It's a great product. It's something we want to get everybody familiar with. Just like everything else, sometimes just having a small piece of information about this equipment can help us get a lot clearer in how we manage these things, help prevent problems and make an installation go smoothly. So that's what I want to do here. Of course, the standard disclaimer, things are subject to change. What I'm saying here is not going to supersede any kind of local code. And of course, we don't want to share any proprietary information without specific authorization from Lennox. So we're going to go over and touch on quite a few different things. Mainly just kind of go over the features of the system, the components, get everybody familiar with it. We'll talk about installation and setup and go along identifying some of the pain points, some of the problems that can pop up. Many times it's just because it may be a feature that someone's unfamiliar with. I think a lot of times working in tech support, that was something I saw a lot with these systems where guys will go out and do an installation, they'll experience a problem, and I always kind of compare it to driving somebody else's car. I'm sure probably everybody in here drives, right? And you're used to driving your car, but if you ever hopped in somebody else's car, if you ever got in a rental car, all of a sudden it's like, oh geez, where's the windshield wiper on this thing? And, oh gosh, it's got one of these little knobs to turn the gear, and and it feels uncomfortable. And so that's sometimes what can happen with these systems. A lot of times we have those skills to get everything functioning and working, but if you're not familiar with what you're looking at, it can be confusing. And certainly it gets uncomfortable with the customer, if you give off that vibe that you're unfamiliar with something. So we'll go over some of these features here. Basically, iHarmony is our communicating zone control. So that's our highest end equipment, the communicating equipment. So we're looking at either the multi-stage or variable indoor units. So our CBA 38 MV air handlers, our SLP 99 furnaces, SL280, and EL296 furnaces. Those are basically what these are going to be used with. You can go, like it mentions here, either 2 stages of heat, up to 3 with the CBA 38, and of course the variable capacity with the SLP 99. So just like with a standard zoning system, you have the advantage of running different schedules in different zones, running different set points, and improving comfort in different areas of the home. Of course, it has auto changeover built into it. The big advantage with these two is that it can adjust the fan speed automatically according to need. So you don't have to install a bypass damper. It runs the blower on its own. Essentially, what you do have to know is the required CFM for each one of those zones. And we'll talk about that a little bit further on. But that's an important step, is just making sure, okay, we know the CFM requirement for each zone. You can have one for constant fan, for heating, and for cooling. Again, for each individual zone, so that can be handy. Again, if you want some zones that want air circulation, but another zone that doesn't, when everything is off, of course. So it can also work as a, what they call vacation mode. You can disable the zoning temporarily and just have it work as a single zone system with the S30 as your main thermostat. You have our onboard fuse in case of emergency. Happens to the best of us, you get a wire crossed or a power surge or something. Built-in 5-minute delay timer, dual fuel capability. If you want to do a gas furnace with a heat pump outside. The one thing that we're going to talk about here too is this pressure switch for the heat pumps. That's a very critical component on here, and it will give you a lot of heartburn on an installation. So we'll talk about how to put that in properly and how we can avoid issues with that. Of course, it's a 5-year warranty in residential applications, and 1 year in non-residential. So we'll go over some of these components. In the box, we're going to get the damper control module and the discharge air sensor. That comes in every one. The damper, or rather the discharge air sensor, I always like to tell guys, it really runs the show. Everything that this guy does off of, as far as sequence of operations, it's going to look at that discharge air temperature. That's the most critical component here. And so it's really important that we get that installed in a proper spot, where sometimes that can happen in the ductwork where you might have a dead spot in there, or a colder spot or a warmer spot, and that's what a lot of times can cause some havoc sometimes in how the system operates and staging the equipment. Either if it's not staging up enough, or it's overheating. Sometimes that's just an issue of where the discharge air sensor is located. We'll touch into that a little bit later on. Your main components, the S30 is always going to be zone 1 on these systems. For zones 2, 3, and 4, you need an additional in-zone thermostat. You need a separate damper transformer to run your dampers, run your damper control module. Of course, your dampers, your free stat, which is an optional component that can be useful in these circumstances, especially on maybe a 2-stage system, or if she's using a single-stage application, it can be very important to use. And then the heat pump pressure switch. So, like I mentioned, S30 is going to be zone 1 always. So you want to be cognizant of where you install that in the home. That's going to be your main control center. The zones 2 and 4 will use the 17A30 in-zone sensor. What's important to know about that is you can adjust temperature there for that specific zone. You can see alerts and things like that, but you can't really change modes or change schedules from that in-zone stat. So a lot of times that can cause some confusion because sometimes folks think that those in-zone stats are like an S30, where you can just control everything from every single component. But the S30 is going to run the show. That's going to be your main control panel and also provide your zone 1 temperature. Anybody have any questions? All right. Feel free to interrupt me. I get excited. I like doing this. So I don't want to run over you guys. Sorry, I got one over here.
So that one is different from the M30s?
Yes, that's a good point. I was going to bring that up because the 17A30 in-zone sensor, the M30, and the ComfortSense 7500 all look exactly the same. They are all completely different. So you can't sub the zone sensor for a M30 or an M30 for a zone sensor. Did that cover you?
Yeah.
Okay. But yeah, that's a good point. I'm glad you brought that up, because that is something that sometimes gets confused. Because if you set them all just powered down on a table, looking at the face of them, you wouldn't be able to tell them apart. But when you flip these over, the zone sensors, they just have a 4-wire connection. Good, because they're communicating they're only designed to talk to the zone board, and that's all they will do. And you can't use a ComfortSense 7500 or M30 as a substitute. So the damper transformer, it's going to be field supplied. We'll tell you technically, you can install these without one. I always tell folks, always install one of these. It just makes things a whole lot simpler, because essentially what this transformer is going to do, it's going to power the zone board, it's going to power your zone thermostats, and it's going to power your damper modules. Now you can set up the zone control to either to do all that with the transformer inside the unit. There's a little dip switch on the board, and we'll look at that a little bit later on. But I found a lot of times when folks do that, if depending on how many dampers that you have, you can start to overload that transformer, especially if you have other accessories tied in, and so it becomes much more of a headache than it's worth. So in my mind, it's always worth just getting that transformer, tying it in, let it power everything, and you don't have to sweat it. Now the important thing is to make sure we have enough capacity out of this transformer. So it's going to be they list some part numbers here for a 40, a 50, and a 75 VA transformer. Essentially what we're doing here is you're going to figure, like it mentions here, the damper control module and 3 dampers are going to handle, or 3 end zone stats rather, are going to handle 6 watts, 6 VA. It's the same thing. So when you're sizing these systems out, if you've got, let's say you're doing a 4-zone system, and just to throw a number out there, sorry to make you guys do math this early in the morning, promise it'll be easy. So if you're doing, a 5 VA damper, let's say, and you've got 4 of them, that's 20 watts. So we know that, okay, with that plus the 6 watts from your damper control module, your zone thermostats, that means we need 26 watts. And with a 40 VA, we've got enough capacity. Now, of course, if you have a much more complicated system, it's most common to have 1 damper per zone. But in some of these homes, that can be a little bit more easier said than done. And so they have to add additional dampers. And so for each one of those dampers, you got to do the math and figure how much power they're consuming and make sure, okay, I might need a little bit bigger transformer. So you might have to sub that in. You can actually do a couple of different transformers if needed. Again, it's not something that's very common, but if it's necessary, there's a diagram in the presentation that talks about that. The diagram and the installation instructions that goes over. A lot of this information is either going to be in the installation instructions or the product specification. Any questions about that? All right. So 24-volt dampers. Basically, we can use any type of damper on here that's not modulating. The system's just going to give us a 24-volt, either open or closed signal. So it can be spring open, power closed, or it can be a power open. It can be a 3 damper or 3 wire that takes 24 volts to open it and 24 volts to close it back again. All those will work, but it just doesn't provide the modulating signal on a system like that. Of course, something else out of the application guideline gives us all the different dampers that we provide, either round or square, and they have the bottom mount and the side mount on here. That's where the damper motor is. Always going to be on that. Basically, on the bottom mount, the motor's on the long side of the square damper. On the side mount, it's on the short side. So FreeStat, excuse me, that's another optional feature. Of course, that's just to protect the coil if we're running, especially as we slice these up into the more zones we get, less airflow we have. Sometimes guys fly a little bit too close to the sun with some of this staged equipment where, even on low stage, we'll see it happen where, okay, you've got a 3-ton outdoor unit. If you're, something like a XC16, even on first stage, it's doing 2 tons. So I want to have like 600 CFM at a minimum, and some folks are wanting to do 300-400 CFM zone. You know, you're flirting with disaster there. So free stack can be a good manner of protection. Maybe not that low of a situation, but if you are in a situation where you might have a zone maybe run a little bit long, if you're having an occasional nuisance freeze up, that can be a good step to take. Now this zoning pressure switch, this is a requirement. Yes, sir. I'm sorry.
I was curious, how would you wire that into your communicating system?
Excellent question. There's actually a spot on the zone board for that. We'll see that a little bit later on. That's a good question. So zoning pressure switch, again, this is a requirement for your heat pumps, whether it's dual fuel or just a straight heat pump and air handler. A lot of times I will, when I'm dealing with problems with these systems, I'll ask guys if they have this installed. And they said, no, we've got a pressure switch in the heat pump. I didn't need it. And, that's basically shows a fundamental misunderstanding of what this little switch does. This is not here to protect the compressor in the same way that the pressure switch in in your heat pump is. The onboard pressure switch that has a 5-strike lockout in your outdoor unit cuts out at just below 600 PSI, maybe like 595, I think is what it's rated at, 590, 595, somewhere in there. Of course, when that thing trips 5 times in a row, or it's 3 times or 5 times, I've slept since then now, looking at the spec, but basically it's gonna lock out after a certain amount of time. So if that happens, heat pump's gone, and you're going straight to electric heat. Now, that gets a whole lot more expensive at that point in a lot of scenarios. So what this pressure switch is meant to do, it wires straight back to the zone board. And it cuts out, you'll notice here, at 550. So the idea is, if there's a scenario where you're running full tilt on a variable capacity unit in heat pump mode, all your zones are open, we're running at 100% capacity. Now maybe 1 or 2 of those zones satisfies. So what happens is the airflow reduces and on your indoor coil, and so that'll bring your liquid pressure up on your outdoor unit. And so what happens is the zone system doesn't automatically, when those zones satisfy, it doesn't automatically stage down the compressor. Or I talked about before, that discharge air sensor is running the show. It's looking at that discharge air temp. So as that airflow reduces, your discharge air temp is going to go up, and then your pressure in your outdoor unit is going to go up, your discharge pressure. So this switch is meant to monitor that and say, hey, my pressure's going up, and it's going to open at 550 before the switch in the unit does, to tell the zone board, hey, my pressure's getting too high, I'm fixing to cut on high head pressure, and that will tell the zone board to either stage the compressor down or shut it off so that it doesn't lock out, and then we're stuck without heat pump heat without having somebody come out and reset it. If this isn't installed, then the zone system says, well, looks like the heat pump pressure is too high. No heat pump for you. I'm going straight to electric heat. And then, the homeowner gets one of those nice $600-700 electric bills, and they're like, this piece of junk doesn't work, da-da-da-da-da-da-da. So this will save you a lot of headaches. I had a colleague at our corporate office that had a new system installed, and the dealer didn't put this in, and she was in all kinds of issue with it, and that's what ended up being the problem, just a step they missed on installation. Any questions on this switch? Yes, sir.
Well, where the control, like the S30 thermostat, will it tell you the pressure? Will you be able to see the pressure, or will you have to tie in your gauges?
It won't show you, it's not a pressure transducer, but you can look at a diagnostic screen that will show you a status of this switch. And basically every input if you have a fully communicating system like this, there's a diagnostic screen in there. And you can look at all the inputs for the zone system, so your discharge air temp, this switch, a free stat if it's installed, you know, all those types of inputs. You know, your zone temperatures, all that information. You can look at same thing for your outdoor unit, like in the new SL28 outdoor unit or the SL25 heat pump, they have transducers in them now. So you can look at those pressures on the diagnostic screen for the AC unit or the heat pump and look at superheat and subcooling. So that's a really great thing to have. But in case of this switch, it's just there to say, hey, open or close. You know, it's not going to give you an actual pressure. Okay, so we'll talk a little about installation here. Obviously, want to pay attention to the installation instructions. Load calculation is going to be important here. And dividing your zones up properly is very, very critical. You want to be aware of that minimum capacity of the system like we talked about before. And, you know, I always tell guys haven't had this call from anybody from Tempo yet, but I remember I was in tech support. I get that call a lot of times from new dealers. You guys who are just getting into zoning and they're like, hey, well, what do I set this zone CFM to? I don't know, man. I'm 1,000 miles away in a cubicle. You know, that's something supposed to be done through the load cap. So that's something we want to have nailed down before you get there, is how to split up these zones and make sure everything's going to function properly. So, of course, we'll do the rough-end wiring, mounting in your thermostats, you know, your S30 and the smart hub. Basically mounting all your components, you know, as far as your damper control, zone stats, S30, all your dampers, you know, mounting your discharge air sensor. That heat pump pressure switch, again, very, very critical. And then you can mount the panel, you know, wiring your damper transformer, and then wire everything up at that point once everything's mounted. That can be real critical just to make sure that you have everything in front of you all at once. That makes things a little bit easier when you're wiring everything up. If you've got all your wires run, got everything labeled and know what's where, that will help avoid a lot of confusion, because, and as we'll go into a little bit later on, a lot of times what happens is guys go out and install these with a roll of 8 wire. So that's just, that'll make you want to cry. I mean, I did a field site visit one time with a dealer where they were having issues with one of these, and it was 8 wire for each damper, 8 wire for each zone sensor, you know, 8 wire for everything. And so, you know, you had all these conductors and it was hard sorting out what's what. Nothing was labeled on it. And so it just made things a nightmare. So taking that step, being precise about it, and making sure we know what's what coming in there is really going to help you sort through issues. Because if you've got, you know, 20 different wires coming at you, it's hard to tell what's what. So basically going through, once you get everything powered up, you can go through configuration. We'll look at some simple steps there, just in the basics of setting up the thermostat. A lot of it's, one thing I always tell folks about these systems, there's a lot that you can change, but there's not a lot that you have to change. The main thing that we'll look at here is, you know, making sure that your airflow is correct. That's usually the most critical point and what causes the most problems with these systems. But outside of that, there's usually not a whole lot that we have to go through to make adjustments on it. So with the damper control panel, again, you want it someplace that it can be accessed and you can run all your wires back to, because again, that's something that all your dampers are going to be wired back to, your zone stats. Usually it's close by to either your air handler or furnace, you know, by your indoor unit. You don't want to be in some area where there's going to be a lot of humidity. You know, it's got its own protective case in there, but you know, you're still going to get some infiltration. And so if you're in an area that's definitely has poor ventilation, has high humidity, and an easy example of a laundry room in here, that's probably not going to be common for a lot of the installations you're going to see, but it's just something to keep in mind if there is if you run across one of those situations. You know, occasionally these get installed in a commercial application, and you'll see those types of issues. One thing it mentions here, you know, don't mount the AC equipment or the ductwork. That can be a critical component. Now, a lot of times when we give warnings like this, it's like, well, we've done a lot of them out there and haven't had any problems with it. And I always tell guys, you know, it's not like once you run that zip screw into the plenum, the whole thing bursts into flames, right? That doesn't happen. But we end up with issues down the road because sometimes it can be just the vibration of that panel can cause some issues, you know, as we get air going through the plenum. You know, sometimes you can get some air leakage in there, get a little bit of condensation. You know, those are the things that we'll look for that'll pop up. So it's best to have these in an area where we're off the HVAC equipment, you know, we're mounted to, you know, a wood joist or stud or something somewhere. Any questions? All right. So we talked a little bit about the S30 and the 17A30. Obviously that S30 is going to be your main control panel. Setup is again pretty basic on those. It's just a matter of powering it up. You're going to see that basic screen here. We'll talk a little about some of the navigation and whatnot a little bit further on. The main difference between these and what you're going to see in an M30 or a Comfort Sense 7500 is our wire connections here. You know, you've just got a power, your communication signal, and a common. These are 12 volts DC. And these are going to wire back into that zone board here at those terminals. Now you'll notice here, one thing you got to be careful with these is it shows a zone 5 terminal here. That is not used, that's a dead terminal. So, you know, I know that none of you have ever been pressured to finish an installation quickly. But, you know, in some cases where that happens, you can say, okay, well here, this is my first zone, bam, I'm going to put it here at the top, right? It's just something to be aware of, you know, that was something that at one time they were looking at expanding these, and that's why you'll see, you know, you'll have a kind of a slash on each one of these. The idea was later on down the road we might go up to 8 zones, and then somebody had a moment of clarity and said, no, it's probably not a good idea. And so that's why that terminal's there. So it's just something to be aware of. If you know, it's dark, it's hot in the attic, just something to pay attention to. You always want to make sure that we're wiring that into to the proper terminal setting. So again, you can just look at some basic information on here. It'll give us those critical alerts and reminders, your model and serial, your hardware number, software revision, those things. That's not going to be something you're typically going to deal with on installation, but again, it's just basic information that's going to pop up. This is a view of what the screen looks like. Again, it's just giving you a status of the system. So you're not going to have that full control that you'll have at the S30. So all that's going to be done at the stat or at the app. Sometimes that's a beef folks will have with these is, well, I can't control everything from here. And usually the response I'll have is, that's what we got the phone app for, right? Who wants to walk over to the thermostat like some kind of barbarian, man? You just pull out your phone. You get a system like this, and then, you know, you're laying in bed at night, and there's nothing better than like reaching over the nightstand and just bam, kicking on the AC, you know, or kicking on the heat. You know, if the wife's like, I'm cold. Y'all probably all heard that at some point. And that's sometimes a complaint folks will have, and I always kind of like to have that in my hip pocket. Is like, hey man, you're not going to worry about that stat. You know, in most situations, you're not going to bother with it because you can control everything from your phone. And honestly, I kind of think the same thing about the S30 in a lot of situations. You know, most of those functions, the vast majority of the functions, you're going to do through the app. So again, with the dampers, we already touched on that a little bit about, you know, how you can use any kind of damper except a modulating damper. Discharge air temperature sensor. Again, this is another critical component. One thing you're going to look at here is this section. You notice it shows 11 inches. sticking out. So basically what it's telling us is to put the tip of the sensor in there and adjust from there if we need to. Because again, that's something that can cause issue with these systems, especially on gas systems sometimes, where it's going to run at a lower CFM and wait for the discharge air temp to rise. And there'll be times where if that discharge air sensor is in kind of a cold spot, in a dead spot corner of the plenum, and sometimes that happens, you know, it used to be we'd tell you to put it halfway into the plenum. But we've noticed that sometimes that can be a little bit of a dead spot. And sometimes it can delay cranking up the CFM and can cause a nuisance limit trip. So you can put the tip in, use that diagnostic screen to adjust it as necessary, maybe a couple different points. And, you know, I always tell guys just to kind of adjust it in there and see how that temperature changes, if it changes at all, and to find a sweet spot in there, so to speak. So your free stat, it's going to clip on the evaporator coil. Yes, sir.
So 11 inches is the max? Is that what you're saying to come out?
It's like a starting point, essentially.
And you
So-
pull out from there.
You would, so you've got your plenum, you're going to stick the tip of it in, and 11 inches of it is going to be sticking out of the plenum.
Okay.
And then from there, you can adjust it inside the plenum, put it further in the plenum if you need to.
And you're gonna base that off the main thermostat.
Yes.
What temperature would you say you're looking for?
It's not necessarily looking for a specific temperature. I always tell guys it's just making sure, because sometimes what'll happen is when you, and you can kind of double check it, maybe with a thermocouple, you know, on temp probe that you have, and see, you know, what the temperature is at that point. Because sometimes what we'll see happen is, and that's the whole thing, it's different with every system.
Yeah.
Because it depends on the evaporator coils that you have. Some guys in Canada don't even have evaporator coils, right? So you won't get a whole lot of turbulence in there mixing the air. And so sometimes it can read particularly warm. So the main thing is just making sure that it's, especially I think, you know, more so even on the gas systems, where the unit will run a minimum CFM, and it will wait for that discharge air temperature to warm up. And if it's in a particularly cool spot, it can keep that CFM at a low level, waiting for that discharge air temp to rise. Meanwhile, the heat exchanger and everything else is heating up because it thinks it's just looking at that discharge air sensor. And if it's reading a little bit colder spot than the rest of the plenum, then it's going to say, all right, I'm waiting until you get warm. And sometimes what will happen is it will finally start to ramp the blower up, but at that point, everything else has gotten so warm it can trip out on a limit switch, or limit trip. So it's, it sounds kind of like a chicken and egg thing almost, of like, well, make sure you're getting the right temperature. Well, what the heck is that? Mainly you can tell that by the operation of the system. So if when you're starting things up and testing it, when you look at that diagnostic screen, you can see how that discharge air temp is responding to the system ramping up. So if you're seeing a situation where I'm at, you know, max output on my furnace or on my AC unit, you know, and it's been running for a few minutes, but my supply air temp is 67 degrees, but, you know, my coil's starting to freeze up, you're like, that's a problem, right? Because if my coil is freezing, I should be moving more air, or I should be back in the CF, or back in the.
But that sensor will kill your system, right?
It will, but if it's reading a warm temperature, it's not going to see that. So
what if I'm charging a condenser and on a cool day, so the house is kind of cool inside already, how would I go about charging it if it keeps killing it off that sensor?
Well, it will, that's kind of a separate issue, because if it's, if you're in a low ambient situation, one, a lot of these systems are going to have built-in low ambient operation with it. But if that becomes an issue, I would just block the coil off with a plastic bag. You know, that would be, you know, just as how you would with anything else at that point, you know, in low ambient operation. The main thing, what I bring up about the discharge air sensor is just sometimes if that can be, you know, if you see an issue where either a system is overcooling, you know, let's say it's freezing up a zone, or if it's cutting out on high limit, sometimes that can be an issue of where that sensor, that discharge air temp sensor is at. It can be thinking that your discharge air temperature is a lot warmer or a lot cooler than it actually is. And so it can overcool the evaporator or overheat your heat exchanger trying to heat up that discharge air temp. So it's just critical to make sure that's an area that's getting an accurate reading if you're seeing some misbehavior. Now, to your point, the discharge air temperature sensor will be used as a quote unquote free stat or a high limit trip. So it's going to monitor that discharge air temp. And sometimes that happens where if you're using this with a single stage system or even on a 2-stage system and we're just not moving enough airflow, we're trying to do a 200-300 CFM zone, you know, either in heating and cooling, your discharge air temp gets too low, and heating, the discharge air temp gets too high, and it will see that and go, all right, I'm shutting you off. So if that's happening on your system and it's one, you're running at maximum capacity with all your zones open, either one, I check and make sure your airflow is correct. And you know, with all your zones open, that shouldn't be that big of an issue. But if it is happening due to low ambient, then really all you can do at that point is block the coil off. I always, you know, had to do that a few times in a couple site visits I've done here recently where you know, in the morning it's 60 degrees outside, sometimes 55 degrees outside, a nice hefty trash bag, you know. I'll block it off until you get that liquid pressure up to 350 maybe. 325, 350 I think is normally where most of our charging charts will say you should be on a 95-degree day. All right. So the free stat, it's just going to clip on one of these tubes here on the manifold. Again, it just gives us a little bit of additional protection. These are the cat numbers here for that heat pump pressure switch we discussed, and this little T. Now, what's important to understand about this thing, because this little guy will get you in trouble. It can be installed in a couple different ways. It can be installed out here at the outdoor unit. You can piggyback it onto the vapor line service valve. Now you have to have 2 conductors going outside specifically to tie it in back to your zone board. Or you can piggyback it here onto the equalizer line port. Where a lot of guys get into trouble with these is they don't take the Schrader port out of this little brass fitting that you add onto it. And so since your equalizer line on your TXV doesn't have a Schrader depressor in it, it doesn't get your evaporator pressure. And your TXV doesn't work. And I can promise you that if you install one of these and then you replace the evaporator coil and then you change the TXV and then you change the TXV again and then you call me because it's a piece of junk and your homeowner's angry, you know, I will step out away from the bus so that it runs you over. Because at that point I can't help you out, you know. You gotta pay attention to that. So again, this is just one of those things that, again, is an easy step, but in the heat of battle, when you know you got 1,000 things to do, it's an easy little step to miss. So just make sure that if you do end up putting one of these in, if we install it there, you know, the purpose of that port is to have a Schrader so that if you install it on the outside unit, you can still hook up a gauge set. But if it goes inside, you got to make sure and take that Schrader valve out of there. Any questions about that? Okay, we talked a little bit about sizing the zone transformer. I'll skip over that if everybody's square with that. Again, this gives us just another basic calculation on determining your damper transformer size. So this is what the zone board looks like as far as the terminal connections and whatnot. On the right-hand side here, you've got your damper connections. One thing that can be confusing on these sometimes is you'll have a common, an NO, and an NC. If you have the NO and NC stands for normally open and normally closed. A lot of times what happens with guys is when they install these in a 3-zone, or if they have a 3-wire damper, where you have a common and a wire to open the damper and a wire to close the damper, they'll put the open on NO and a close on NC. But it should be reversed, because on a 3-wire, that NC terminal, it's counting on it being normally closed, and so it's going to put 24 volts there when it wants to open the damper. So if you've got a 3-wire setup, you put your open command on NC and your close on NO. Just one of those little quirks of installation. It's another common one, unfortunately, where guys are like, this unit's not keeping up. This customer's angry. And I'm like, it's overcooling this one zone and this other zone is burning up hot. Did you check your zone damper wiring? Yes, I've checked it. Did you check it again? Yes, I've checked it. Did you go out there and check it yourself with your own eyeballs, or did you trust someone else to go out there and look at it? Yes, yes, yes. And I go out there and it's crisscrossed. And it's like, oh man, and again, I'm not gonna lie to you and say none of this stuff has ever happened to me. It's just, again, a lot of that basic stuff. It's amazing. It's really amazing, because if you put a blue shirt on, like I've worn a blue shirt like that, if you put a blue shirt on, nobody thinks you know anything. But as soon as I put this nice red shirt on that has Lennox on it, I'm a brilliant genius. I'm a brilliant genius. It's like I soldered this thing together in my own garage. But there's so many times, where I tell guys, when you're going out and troubleshooting these issues, we tend to build it up, especially if you're your 3rd or 4th trip out there, where it's like, man, this has got to be a big issue. This has got to be something that no one has ever seen before. But so many times, the first thing I'm going to do is go out there and just look at these basic issues. Is everything wired up right? Is it mounted correctly? Is everything placed where it's supposed to be? Because usually that's where we start having these issues. So something else that's good to know about these is you have these damper lights. I don't know if you can see that on that picture there. They're going to indicate, they're kind of reverse logic. So they're going to light up when that damper is closed. That's something else that can cause some confusion on these. So I've experienced that going over the phone with guys on these, where the thought is, oh man, this thing's, the light's coming on telling it to open up, but it's closing off. And I tell them, no, it's the reverse. Here on the left-hand side is where your zone sensors are going to get installed. Again, they're 12 volts DC. You'll have a power, a common, and then a plus and a minus. That's basically a comm light for your zone sensors. Of course, you'll have your fuse, and then your terminals up here where we'll connect the discharge air sensor, your heat pump pressure switch, your free stat. There's a bridge that we'll install there from the factory. A blower sense terminal, which isn't really used in most situations. And then your damper transformer and the transformer jumper. We'll talk a little bit about that here coming up. Yes, sir.
Is it required to wire up the leftover wires? When you run into the thermostat and you say that you run an 8-wire and it only takes 4, is it required to wire up the leftover 4?
Yes. So 8-wire haunts my dreams at night.
or a 6 wire. They say like a 6 wire, and then like you go to the S30, and you only use 4. Do you wire nut the?
Yeah, you want to wire nut those and take them to common. What we've noticed with these systems, the longer they've been out, and especially with the fact that we've got our smart hub as a separate component, you'll notice here, I always like this, the loom of doom. Something one of our internal guys, he uses that term a lot. I kind of coined that. He kind of discovered how that could be an issue. But it's not just a matter of having the extra conductors picking up interference, but what they've discovered is that having the AC and the DC in the same jacket, that's what can cause a lot of these communication issues. So you notice here in this diagram, we're showing 2 runs of 2 conductor wire. So your RNC, your 24 volts, will be in a run of 2 conductor conventional thermostat wire, and then your I plus and I minus will be in a 2 conductor shielded. So that's the best way to prevent issue with these, is shielded wire. Or bare minimum, again, talking about the site visit I told you about before, where they had 8 wire run for everything. And again, they're just getting beat over the head with communication issues. I took because a lot of times the most critical point here is going to be this connection here at your indoor. Because you'll notice what they have here is the wiring from your smart hub and the wiring from your zone board piggybacked onto those indoor terminals. That's your furnace or your air handler. That seems to be the most critical component there, where the hub's talking to the furnace and the zone board's talking to the furnace. And I've had a lot of situations where if they're having communication issues or just nuisance problems, I'll say at very least, because usually you can reach out and touch the zone board and the smart hub from where the furnace is or the air handler is, or it's somewhere there close by. Be like, hey, go to Home Depot, get you a run of 2 conductor wire, and have that in your back pocket, because there'll be a lot of situations where I'll be like, take out that 8 wire, get you just a basic run of 2 wire, run 1 for your RNC, run 1 for your I plus and I minus, and just getting those out from each other can prevent bleed over. Because you'll see that a lot where even with the wires grounded, if you check with just RNC hooked up, the additional wires, you'll get some bleed over. You'll get some inductive voltage. Kind of basically just how like a transformer works, where you might get 5, 6, 10, 12 volts AC on your DC communicating wires, and that's what can cause a lot of those issues. So that can be a real critical point here, is separating the AC and DC voltage. So it's, again, that's best practice for these. I know a lot of times you may not get to make that call out on the job, but that can be a critical point, especially if you're experiencing troubles at startup. But you'll see it shows taking, in this case, the ground wire from a shielded cable back down to common, but you do that same thing with additional conductors if you're using multi-conductor. But like I say, if you can eliminate that, at least in your wiring from the communication wiring from the zone board to the indoor unit and the hub to the indoor unit, that will do a lot in just running 2 conductor there. So again, this is our zone stat wiring. Again, zone 5 we're not going to use. It's a dead panel. It's a dead terminal. Since this is all DC, again, running that 2 wires going to be your best option to prevent issue. It's a little bit less critical in these scenarios where we're just dealing with DC. Haven't seen as much issue communicating, but that can be a good thing to use. Again, your damper wire is just going to be 2 wires. It's very, very basic wiring there. Another critical point here is wiring in our zone transformer. We'll talk a little bit about phasing this, but that's an important step. This is the extended zone stat or damper. Sorry, I don't think I had enough coffee this morning. This is so if you have a scenario where you've got, in this case it's showing 8 of them there. Zone dampers. This shows how to tie in a secondary transformer if need be, using isolation relays. This is a diagram that's in the manual, but it's an option that's out there if you need to, if you're using a lot of dampers. Any questions so far?
I have a question on your.
Real quick, you're pointing something out with your mouse. We don't see it on the screen.
Oh, thank you for telling me.
So, I just lost my question, but okay, I'm ready now.
Okay.
On those controllers, do they already come updated with the latest firmware, or do we have to get it from your website to update them? Because there's some certain manufacturers where you get like a high-end system, and they'll give you an outdated thermostat, and you have to update it. Does Lennox already provide the thermostats with the latest firmware updates?
It has the latest firmware update from when it was manufactured. So we haven't figured out a way to update a powered down thermostat in a box yet. But if we do, we'll be the first to know.
Okay.
But in seriousness, they will go through. Sometimes that happens where you get something that's, we may have just dropped a firmware revision recently. And so what'll happen is, and this is an important step, just with the S30 in general, whether it's owned or not, is if you get one that needs a software update, when it gets connected to Wi-Fi and registered, and to the point where you can control it from their cell phone, that's the important thing. It's not just connected to Wi-Fi, but it has to be registered. So they have to download the app, create an account, and get to the point where they can control it from the dashboard or from their phone app. At that point, then it can receive software updates. And that can be a thermostat, it can be a zone stat, it could be a control board in the unit, heat pump control board. A lot of these newer boards and components that we're coming out with that are manufactured and spec'd by Lennox, we're starting to put that capability in them. So that's an important step to take, because that's not uncommon for that to happen, where you do an installation and that first night it may go through a firmware update. So it's important to make sure that they get connected to Wi-Fi and get everything registered properly. You were just telling me my mouse didn't show up. Okay, just want to make sure I didn't forget you. Okay, so with the indoor unit wiring, it's again just another important thing to catch on. It shows these wiring app, your smart hub there in the top left and the indoor unit at the bottom, or rather the zone board indoor terminals. Those both wiring back at your indoor control. So what it's telling you to do is to piggyback 2 sets of wires there in those indoor terminals. Now, I like that as much as you guys do. Sometimes it's not fun squeezing 2 sets of wires up in there. But getting a good screw terminal connection on there can be really critical, because wire nuts usually end up causing issues with us when we're trying to get good connections, and can cause nuisance issues. So another critical point. So your outdoor unit is going to be pretty straightforward at that point. You have a couple of different options, because these can be used with non-communicating outdoor units. But in a communicating system, you just need your 4 wires going outside, or RI plus, I minus in common. Again, if we can do that in 2 runs, a 2 conductor, that's going to be the best thing we can do for future operation. If you end up installing on a heat pump The pressure switch out there, remember, you'll need an additional 2 conductors outside for that. Discharge air temperature sensor, again, just wire straight to the zone board. It's just a basic thermistor, so it doesn't matter. You can switch those wires any way you want. Heat pump pressure switch, again, that's going to wire back to that zone board with the pressure SW terminals. And then your freestat will have this little bridge installed there from the factory. So if you do end up having a field installed freestat, you just take that out, pop your freestat in. Piece of cake. Questions about that so far? Yes, sir.
So if you want to connect the safety switch, and if it's like communicating, you don't want to cut the R, or is that okay?
That's a good question. With a safety device, that can be installed. We have a separate diagram for that. I don't think I've got it covered in here, but that's something I can send to Uwe that he can share with you guys. What we recommend doing is using an isolation relay and having that break the common wire to either your outdoor unit or your smart hub. Because what'll happen is a lot of times those float switches, they're a no price, too cheap kind of component, right? Where they usually don't have the best set of contacts in there. And especially as things are shimmying and shaking, with an evaporator coil, as you get air running through there, if it's get just a little bit of vibration, you get a little bit of rattle in that switch and that contact. And if it's breaking R, that can cause some noise and give us some issue. So what we found is if we use an isolation relay and have the contacts in a relay break common instead of R, then when the float switch, what it will do is you can just run 24 volts through the switch to the coil of that relay, and then have the relay trip and break common. That's really confusing when I explain it without the picture, so I don't expect you to understand that, because I didn't understand it until I saw the picture. But that's something I can share with Google and get out to you guys, because that's another common point that can be, again, a source of trouble with these. So you have your damper transformer. Again, this is the jumper pin I was talking about, where you can select here whether you want to use the damper transformer or the system transformer to power the zone board and the dampers. Typically we'll just leave that at damper transformer because we'll have a separate one tied in. Transformer phasing here is very important. So one thing that you'll look at whenever you tie the system in and start it up, this is something you all want to do on startup, is check the R from where your damper transformer ties in to the R where your indoor unit ties in. So you're going R to R there. If everything is in phase, you should have 0 volts, or maybe 1 or 2 volts. Very low single digits. If we're out of phase, then you'll see 48 or 50 volts there. And at that point, all you have to do is swap your plus and minus wire there. Or rather your R and C coming from your damper transformer. So with setup, not a whole lot of setup that has to be done. I know we're getting short on time here. Yes, sir, I'm sorry. Oh. You gotta just make up a question at that point, man. Just roll with it. Yeah. I'm sorry. Estaba pidiendo café.
It's going back on that safety switch thing.
Mm-hmm.
Is it okay for us to break the transformer?
I wouldn't break the transformer.
Why not?
For the same reason.
Same reason?
Yeah. That's something else that, again, we've just seen cause some nuisance issues. So, I kind of use the bursting into flames expression, where a lot of times I'll tell guys that, and it's like, well, we got a lot of them out there that are working. I'm sure you do. And as I drove here up Loop 12, I'm sure there's a lot of cars that had like bald tires and crummy brakes and that were, you know, loaded up with a bunch of junk that would get to point A and point B every day, right? Until they don't. And so when we talk about these best practices, usually it's a matter of, hey, yeah, you can do it other ways, and it may work for a given period of time, but it's just another link in the chain that can be a potential problem, you know, be a potential nuisance call down the road. And so if we can eliminate as many of those things as we possibly can, then it eliminates problems at startup and callbacks and things like that. So, you know, that's just one of those things that may not cause a problem every time, but we've seen it cause issues, you know, especially with these communicating systems. You know, on the fully communicating systems, that's a critical issue. A non-communicating system, not as big of a deal, but with those communicating systems, that can be a source of nuisance issues. So a couple things we'll go over. Start up here. If you're using a non-communicating outdoor unit, on these systems, you have to clip these jumpers. So if you've got a non-communicating heat pump or a two-stage system, you'll have to clip, for example, well, actually, because my mouse don't show up. That middle one is there for heat pumps. So if you've got a non-communicating heat pump, you clip that one. If it's two-stage, you clip the one at the top there. And you have to go through a function to add that as a non-communicating piece of equipment there on the S30. For the on an air handler, of course, again, if you've got multiple electric heat stages, you want to take that little jumper off of there. If you're using like a 15 or 20 kW heat strip on there. So as far as setup's concerned, I know we're running low on time here, but basically going through your wiring, make sure everything's identified properly, installed properly. The phasing on that damper transformer is going to be critical. Making sure that our heat pump pressure switch is installed properly. Another thing that you'll look at here for communication is this 2.5 volts DC. We're checking for proper communication between all your communicating components. You're checking common to I+, common to I-. On your zone sensors, all your communicating equipment, that's going to be your money in the bank as far as your comm signal. If that's 2.2 or 2.3, or if it's 2.7 or 2.8, that can be an indication of a problem. And there's, you know, it talks about this service note here. That's something else I can share with you that has some good additional steps for troubleshooting. Just kind of a quick reference to say, okay, what should I have at different processes as I'm wiring things up. So if you do have trouble, you can help narrow it down to a wiring issue. So with startup here, so I say there's a lot that can change, not a lot that you have to change. This wireless accessory configuration, all this is a mode. It's kind of like a discovery mode for Apple HomeKit with the S30. You can just cancel this out. It's not anything that's important. That's something that can actually be switched off. We'll get our dealer info setup screen. This can be a critical point to allow y'all to be able to see things on the service dashboard. So you can put your dealer ID or phone information. You can do that down the road as well. It's not something that's critical that you have to do right here. If you don't put that in, it's going to give you this screen. It says an alert saying, hey, you don't have your dealer info in here. Your time and date. Again, that's something that can be adjusted down the road, but it's typically handled through the internet, at least for your time and your time zone. This can be a critical point telling us what equipment's found. So obviously, if you're installing a system and your zone board doesn't pop up, or your outdoor unit doesn't pop up, and you've got a communicating outdoor unit, then we know we've got a communication problem. So this can just be a handy way to say, okay, it will not show all of your zone sensors, but it will show your zone board, show your indoor unit, and your outdoor unit, of course. This is just reminders. Again, that's not something that's really critical. Here's where we can name your individual zones. You can just select one of those and edit it. When we get into this screen in the Dealer Control Center, you'll have your test screen. You'll also have the diagnostics there. That diagnostic screen is really, really critical in checking out the discharge air sensor. When you select that diagnostic screen, that can be used here at this point in initial startup. It can be used as the system's running. When you go into the installer setup mode, you can look at the input on all your sensors and all your communicating components and see the status. So that won't do away with it won't shut the unit down. It won't interrupt your call, so that can be handy. But when you're doing initial startup on these, you can select that test option, and it's going to take us to the zone CFM setup screen here. So you can make adjustments for your heating, cooling, constant fan airflow for each one of these zones. And then it will take you through a test mode. You can either do an automated test or manual test. So you can test each one of these functions. Again, you can go back into the install setup here and test any of these functions. If you want to test the blower on its own, cooling at minimum or maximum rate on a variable system, or stage 1 or stage 2 in the multi-stage system. Same thing with your gas heat. You can uncheck those and select them individually if you wanted to do that. In the equipment tab, it's going to give us our different menus to make adjustments in the system. Most of what you're going to need to change there is in the Smart Hub, air conditioner, and furnace tab. And again, there's a lot that you can change, not a lot that you have to change. In your furnaces, this is where you're going to adjust your low cooling and high cooling airflow. Same thing for your heating CFM. For heat pump systems, you have to go to the heat pump tab to adjust your airflow for some reason that I have not yet understood, but just another little quirk. So in that zone control setting, that's where you adjust mainly your temp calibration. There's, again, not a whole lot that you'll need to adjust in there. The thermostat is, again, just basic display settings, things like that typically you don't have to play around with too much. And then the add or remove non-communicating equipment is where we could add in a fresh air damper, HRV, ERV, something like that. So that's what our main screen is going to look like. One of the critical things that I'll tell you guys to pay attention to are these 4 dots here at the top. That can be a very quick indication of whether zoning's functional or not. Because if you have a zone system and you don't have those dots, we're not in zone mode. So a lot of times that either means the discharge air sensor is not installed, or we're having communication problems with one of those zone sensors, and it will eliminate zone mode. So just a quick check there. If you see those dots, then we know you've got communication with all of your components there. As far as airflow, checking static pressure is essential. That's going to get us out of a whole lot of trouble. So, of course, on a furnace system, if we can check it between the furnace and coil, that's ideal. As far as your supply status is concerned, we can check it after that point and do math there on it. Yes, sir.
I have a question. What are these furnaces rated on static pressure?
Man, now we are asking the proper questions here. Basically, you're looking at 1 inch. I think I've got a slide in here that shows it. On the larger stuff, it's 1 inch. I think like 4 and 5 tons, like 3.5. I think the max is 0.8. It says it there in the spec, but that's an important thing. And that's really critical on these, is to make sure we don't get cut back, because this will tattletale on you. If it's trying to ramp up and it meets high static, then it's going to throw a code, and that's going to be noisy, and it's going to cause you a lot of heartache there. So the checking that is critical, and also talking about that diagnostic screen.
The reason I'm asking is because we had, the job we did, the system kept turning on, and we came to the conclusion that it was
That scenario is very important. We touched on earlier about the zoning and being able to adjust each zone. That had a lot to do with that. If we have a small zone, we got to make sure we adjust the right CFM to that zone. Otherwise, it doesn't work right. So when you go into the settings, as you go through all the settings when you first start it up, there's a spot, and most people skip it. It tells you each zone how many CFM that's adjusted, and with more classes and with information from the comfort advisor, we should better know each zone, how many CFMs to adjust that to. We went back a couple times, and I think I spoke with you over the phone, Mr. Brandon, and we were able to figure it out that we have to adjust each zone to a certain CFM. And that was causing the unit would vibrate when you had a smaller zone running triple the CFM it should be running. There was times with the unit would even vibrate. Homeowner system didn't shut down. It was just the noise that it was creating for having one zone open with more CFM than what it can handle. That's very important.
Yeah, one thing that you can do here is I always tell guys, run those zones individually on their own, and then you can go into the diagnostics for the zone board. You go in the installer setup, in that diagnostics tab, just check the zone board, and in that diagnostic screen, or rather, I'm sorry, not the zone board, but your furnace or your air handler. And in that diagnostic screen, it's going to give you indoor blower power. So really we want to keep that, like it says here, below 79%. If you're up in the 80s and 90s, that's an indication of high static. So that diagnostic screen also for the zone board will let you look at the discharge air temperature. That can be another indication where if the discharge air temperature is high, in cooling or low in heating, that can be an indication that we're running way too much airflow. So indoor blower power is, it's kind of a poor man's static reading. So if that's high, then we need to reduce that CFM, or we need to rework our ductwork. Or we've got a damper stuck closed, something miswired, something like that. But that's an indication there that our blower's working too hard and we're gonna have problems down the road with it.
I have a question.
Yes.
Going back to the CFM, how will we get the CFM for that room or for each individual zone? Will that be like for a comfort advisor to tell us that this room needs, let's say, 300?
Yep.
Or do we have to do our own calculations for that?
Oh, that's something that,
And a little bit of both. So
Okay.
with the help of compromises and knowledge, we will figure that out. So if it's just on this size, we gotta know how many CFM that's on to be put down. And also they'll be provided that.
Will that be just in communicating systems or both communicating in regular two-stage?
yeah,
or?
for communicating and non-communicating. That's something we want to have an idea of before we get out to the job. Now, that's why I always tell folks to run each zone individually when you're out there, because that's what the homeowner is going to do. And if you set up that CFM level, and if it's a little bit too high, if it's too noisy for somebody, then you want to handle it right there.
So on the non-communicating, how will you adjust it? Will it be through your dip switches or?
Yeah, so like on the Harmony 3 zone panel, it has jumper pins that you'll adjust the CFM for.
And that will be for each damper.
Yeah, for each individual zone. So again, on the larger systems, that max is going to be 1 inch of total static, then we'll go down to, like I say, I think it's 0.8. I can pass that on to Google when I review things afterwards. Sometimes what you can do is have this happen a few times where if you have, again, a zone that's maybe a little bit too small, some of these dampers that you can adjust to where they don't close all the way and may allow a little bit of air to bypass into a larger zone. That might help us move a little bit more airflow if need be. There's a static pressure worksheet that, again, can be just a good thing to fill out. It shows your static pressure for each one of those zones that can save your bacon in the future. If there's problems down the road, somebody changes something, just to show that everything's working at startup and, within tolerance. So we talked a little bit about the LEDs. I'm not going to go over that too much again. Again, that's something that's clear in the installation instructions. But usually if everything's working in there, the green light, just as green light's going to be on, indicating that everything's functional.
I got a question. Fresh airs. I know Honeywell has two bar fresh airs. They go to the A1. Is it A1, A2?
Yeah, it's
But then when you got fresh airs that are 4-wire that have that module, where would, or is it would it work with,
Like our Harmony,
So-
like with our Harmony setup to do fresh air.
So the iHarmony won't, but the S30 will. That's a good question. That's going to tie into the S30. The S30 Smart Hub has 2 accessory terminals, and those are dry contacts. So you can use them as a switch for a fresh air damper. Now,
With our the S30 thermostat itself, like you said, it's a fresh air or
exactly, yeah, you go through the setup there. And that's something, again, you can, we were looking at the screen before in that equipment tab. You go in the installer setup in the equipment tab, there's an option there that says add or remove non-communicating equipment. You can do that there. That's where you can add it and say, hey, I've got an outdoor air damper, and we'll use that accessory terminal there as a dry contact to switch it on. Now, it doesn't know what you got or how it works. All it knows is that when I need fresh air, I snap that contact closed. So, depending on how that Honeywell system works, we'll give you a switch, but at that point, I don't know how that system works, but one thing I would tell you, if you run into a situation like that, a lot of guys are really familiar with our tech support line, but our product application support line is great for that sort of thing. So if you've got a product question, if you're either pre-installation or in the middle of installation and you've got a question about wiring something in like that, I don't mind helping you out, but occasionally I'm doing something like this and can't answer the phone, or in a meeting or something like that. You can call 1-800-4-Lennox. If you press 2 and then 1 and then 3, that should get you the product applications department. That's where I used to work, and so they can help you through with those types of issues and just getting clarification on things. Sometimes guys are just like, hey, I'm putting one of these in for the first time. I'm unclear about this or that. I got a few questions, and I can help you through that as well. Okay, coming down towards the end here. So again, basic's going to be your 5-minute delay, or your green light, your green status light if everything's working. Usually that's the only thing that's going to be on. You got the 5-minute time delay built into it. As far as your sequence of operations, continuous blower is going to work only when everything's idle, because obviously if we're getting a heating or cooling call, it's going to close off to an individual zone, but you can set that CFM for each individual zone set up there. The auto changeover, again, something not something that y'all are going to deal with a whole lot, but essentially what it will do in one mode, it'll run for 20 minutes at a maximum trying to satisfy. If it needs to change over, it'll shut things down and run for 20 minutes in the opposite mode. A lot of this is things we've already discussed, but probably the only other issue to be aware of, if you're doing a dual fuel setup where you've got a communicating furnace and a non-communicating heat pump, we're going to require an EIM module for communication there for that to be able to function. Something else that's good to know about these, if you're getting dashes there on the zone control or on the zone stat, that's going to be an indication of communication problems. So just something to be aware of. Again, that's where you look at your comm signal. Kind of been over the discharge air sensor, the zone stat and what we're going to see there. As far as diagnosis on it, it's a thermistor. You can just check ohms across it. There's a temp resistance chart in the installation manual that'll tell us, what that's reading if it's correct. We talked a lot about this zone pressure switch. It's just an on-off. You're going to ohm it out. It's either going to be closed or it's going to be open. Again, something that's just very basic. And then you'll have your alarm codes. 105. We talked a little about communication issues. That's a specific code for the damper control module. The 31 is going to be a comm issue with any component there on the system. So talked about checking your transformer phasing, making sure that transformer selection is proper, and again, that's something that probably not going to have to adjust in most setups. I think that's about it. Anybody have any questions? Sorry, to zoom to the end of it.
That communicating equipment, that bridge that you cut for two-phase or the heat pump,
Mhm.
you have to do it on communicating as well? Or just,
No, just on non-communicating. Yeah, so if you have a communicating indoor unit and a non-communicating outdoor unit, that's where we'll clip those little bridges on the control board. But if it's a fully communicating system, you don't have to clip anything. Now, if, usually the next question is, if I do clip one of those, how do I fix it if I didn't need to? There's 3 of them on there. So you have a Y1 and Y2, and that just jumps Y1 and Y2. You can just jump Y1 and Y2 with a little piece of wire. The other one's R to O. For your heat pump, again, you just jump R to O on the control board. R to DS, same way for the other one. So if you do that by accident, you get you a 6-inch piece of wire. We'll fix it for you. Yes, sir.
You say you worked in the research lab for Lennox?
Yes.
Why hasn't Lennox went to EEV valves?
I'm sure that there's someone in there working on that right now, but I really don't know why. I worked in the lab 20 years ago, so I've slept since then. But that's another question that folks will ask, and I don't have any advanced knowledge, and I wouldn't tell you if I did, but it's kind of one of those things where I see that train coming, because everything's getting variable. We're getting those higher SEER. We're getting transducers, pressure and temperature transducers on board on the unit. So to me, that seems like, more and more signs that we're moving in that direction. So I wouldn't be surprised to see that, over the course of the next several years, but haven't heard anything about it so far. All right, that about it?
Thank you very much. Thank you very much.
My pleasure, my pleasure.
Thank you all for being here. Man, appreciate it. Your cooperation. That's very helpful. The questions were great. Thank you all very much. This is resumed today's training. Thank you.